In our last video, we talked about ways which we could, or ways to talk about angles between two parallel lines that are cut by a transversal. Some that were congruent, some that were supplementary. Now, I want to think about or work through some ways that we can show that lines are parallel given the angles, okay? And so it's almost like we're kind of talking about biconditional statements here, which is really the opposite direction. And if you watch my last video, then these should be pretty, maybe, I don't know if self-explanatory is the right word, but they should be familiar. So if two lines are cut by a transversal and the corresponding angles are congruent. So remember, last time I always labeled these angles 1, 2, 3, and 4, 5, 6, 7, and 8. And now I'm told that if two lines are cut by a transversal, so I don't know that they're parallel lines, even though they look like it, I don't know that yet because I haven't proved that. But I do know that the corresponding angles are congruent. So I know that we're going to do this. Angle 1, angle 2, angle 3. And I only need to know one of these pairs, right? Only if one of these is true, if one of these corresponding pairs is true, then the rest will follow, which is kind of crazy to think about, honestly. So angle 1 then is congruent to angle 2. And this is what I'm saying. This is my given. Or angle 2 is not angle 2. So silly. Angle 5. Or angle 2 is congruent to angle 6. Angle 3 is congruent to angle 7. Or angle 4 is congruent to angle 8. And like I said, you only need one pair. You only need one of those pairs to be congruent of corresponding angles. And if any of those are congruent, well then the lines are parallel. So that means I would say, maybe I can, this is line L, M, and N. Then M is parallel to N. It's like little parallel lines. Okay, if any of those corresponding angles are congruent, then the lines are parallel. Okay, what's another way to show that lines are parallel? If we've got two lines cut by a transversal and alternate interior angles are congruent. So this is kind of like the last time. We've got 1, 2, 3, 4, 5, 6, 7, 8. If angle 3 and angle 6 are congruent, or angle 4 and angle 5 are congruent, if either of those are true, then the lines are parallel. Because if one of those is true, then the other would be true as well. If you think about this, right? 3 is supplementary to 4 and 5 is supplementary to 6. So if 3 and 6 are congruent, then 4 and 5 are also going to be congruent, right? So you only need to know one of these. Again, you only need one pair. Then the lines are parallel. So again, we'll call it M and N. So M is parallel to N. Just imagine those are cursive. Use your imagination with me. Okay, if two lines are cut by a transversal and same side interior angles are supplementary. So we talked about this again in the last video. 1, 2, 3, 4, 5, 6, 7, 8. If angle 3 and angle 5, or angle 4 and angle 6. I'm saying this isn't even an if. I guess it is an if. So if these add to 180, if they're supplementary, then again, the lines are parallel. Just like that. Okay, we've got 2 more. So there were 5 ways. If 2 lines in a plane are perpendicular to the same line, then those lines are parallel. So we got to draw our own here. Throwing me for a little bit of a loop. Guess I can try to keep the colors somewhat the same. So those arrows are really big, but that's okay. Okay, so I've got 2 lines. If they're perpendicular to the same line, so they're both perpendicular. Maybe I can label these. So here's L. Oh, my brush is really L and M and N. So this is perpendicular to M and N. Then those lines would be parallel. Let me write this. L and M. Oops. What happened? M are perpendicular. And also L and N are perpendicular. So L and M are perpendicular, L and N are perpendicular. They're both 2 lines perpendicular to the same line. Then M is parallel to N. And I really hope you can see that. I know that's a darker color. Maybe we can change it up for this last one. So the last one is if 2 lines are parallel to the same line. We'll use a few different colors here. So here's one line. Here's another line. And here is my 3rd line. We have, I don't know. Here's line C. I'm just going to keep it simple. Lines A, B, and C. If, and I'll kind of use colors for this, if line A, I know that line A thanks for letting me fix my arrows. I know that line A and line B are perpendicular. If I can so difficult to do. Okay. I know that line A and B are perpendicular, and maybe another color, I don't know. Pink seems like a good one. I know that line B and I'm going to use 2 arrows. I'm using different colors, but I'm also going to use 2 because this is how you would show that different lines are parallel. I'm just using 2 different colors so that it's easier to see. So I know A is parallel to B. A, oops, and we're just gonna, A, oops, A is parallel to, A is parallel to B. And I know that B is parallel to C. Then I know that A is parallel to C. So I know that they're both perpendicular to the same line, so then that means they're perpendicular to each other. It's like the transitive property for parallel lines, right? If A equals B and B equals C, then A equals C. It's the same idea. Okay, that was kind of a rough ending, but I hope that that helps you see ways which you can start with lines that aren't parallel and show that they are parallel.